I'm Andrew Smith, and this is my video lab report for Lab 9, which dealt with the energy changes in the oscillation of a spring. A video of a spring moving both up and down as well as side to side was analyzed. This was done in both Tracker and VPython. I first downloaded the video off of WebAssign and imported it into Tracker. I began looking at the spring and mass system as the mass was released. I set the origin of my axes at the specified point on the video. I then used the calibration stick to set the length of the stretch spring at 0.7 meters. I then put in the weight of the mass, which was 0.402 kilograms. The initial conditions for the lab were found from the in-lab assignment. This is where we calculated the values for the stiffness of the spring, as well as the initial stretch of the spring. The rest of the initial conditions, such as the weight of the mass in the spring, were given values. In the lab, we were required to calculate various energies pertaining to the spring. The three energies that we were told to look at were kinetic, gravitational potential, and spring potential energy. The three were calculated with the equations shown here and were continuously updated as the simulation ran. For the first what does it mean question, the two periods differ by about a second. This could be due to the fact that the spring slows down at the top of its arc while it is swinging. This causes the two periods of oscillation to not be in sync, therefore leading to the differences seen in the lab. For the second what does it mean question, the energy principle is still satisfied. Previously, although we ignored the spring potential energy, it was still there in the form of work. Now that it is a part of our system, the right side of the energy principle equation changes to match this. For the final what does it mean question, the value for the spring potential energy would change. This is due to the fact that the S value for the spring potential energy equation would get smaller if we got closer to the mass, or larger if we got farther from the mass. This error can cause the illusion of the energy principle breaking down, when in fact it is just an error in measurement.